Hi, my name is Jonas Grunditz and this is my presentation of Assignment 2 in Neural Network and Deep Learning. First of all, I'm gonna go over the script that I have been reading and then I'm gonna demonstrate that my code is actually working. If we start with the feed forward function, we will see that we are entering the weights, the biases, and also the value of the previous node. And we will get the activation value of that actual node. And then we're returning that one. If you look at SGD function and we go down to the test data and we know that we actually have test data, then we're gonna call the functions training data and also the test data. And they will result in different measurements, which will be saved in these variables. These variables will then be printed and we will get performance evaluations for measurements like MSE and cross entropy, log likelihood and correctness, also accuracy. We will append these to the empty list that I have created up here, and we will append as the training performance evaluations to the performance training list and the opposite for the testing data. And then we're combining the performance of the training data and the performance of the testing data to one list, which is called the performance combined. And then you can print this one if you want to. This is the early stopping regulation. So the accuracy will stop the loop if the accuracy is above the term %, which we are setting when we're calling the function down below. If we do not have test data, we will only do all the things we've done up here, but only for the training data. So if we keep going down, we have the back propagation function. And here I have made some changes to optimize the code and make it less complex. Before it was adding a layer at a time, but now we have created the activation structure, which is already holding all of the arrays, so we can just put in the values. And you can see that we're creating 3 arrays, which has 20 inputs, 7 inputs and 3 inputs, and then we are appending those arrays to the activation list. And for each of the iterations from the for loop, we are adding that to the list. So during the first iteration, we get an activation, which is an array for the activation values from that iteration. So first is the hidden layer, which will be added to the activations. The second one is the second hidden layer, and the third one is the output layer. And then if we go further down, we will see the evaluation function, which is the first one is adding all of the activation values from that run into A. We're making that to an array. And then for every activation value, we're adding that to a list. And we're using that list when we are calculating the mean squared error, which is the predicted value minus the actual value that we wanted. And that is, if you divide that by n, we get the mean squared error. Further on, we can calculate the cross entropy, and that is the same thing. We're using the activation values from the previous run, and we are using the value that we wanted. And depending on the values on the activation value, we will either use this part of the function or this second part of the function. then we divide it by n. The calculation of the log likelihood, we are using we're using the activation value where which is one is hot, which means that if we have a 1, then we're using that activation value. And now we can test our model, and we start with 0.6, and you will see that we get 33 approaches, and we can change that to 0.7 if you want to, and we will get a different number. We will get 95, and we can also change that, so we will get 0.8, and we should get 125, which is correct. So we were loading the structure of the network, which is 4 nodes in the input layer, 20 in the first hidden layer, 7 nodes in the second hidden layer, and 3 in the output layer. And this is some of the measurements that we can change to increase the performance of our model. And this one is the number of approaches. This one is the size of the mini batches, and this is the learning rate. Thank you very much, and have a good day.